We're going to start off the trigonometry unit with a review of the right angle trigonometry that we did in Math 10C. So for the first case, if we're talking about the ratios of right angle triangle, well, here I have the right angle triangle AOB going from A to O to B and then connecting it all as a triangle. In this case, we're going to state that the angle between AO and OB, or the angle that occurs at O, is going to be x degrees. And we're going to state that each of the sides of the triangle is given a special name specifically relative to x degrees. So the longest side of a right angle triangle is always the hypotenuse. The side that stretches along here and is opposite the 90-degree angle. The side opposite of angle x, which in this case is AB, is called the opposite. Another way to think of it is the opposite side is always going to be the side length that the angle does not actually touch. So we can see here the angle is created between the hypotenuse and this other side length. The third side length is going to be the opposite. And lastly, the remaining side, OA, is going to be called the adjacent. Adjacent means beside. The other way you can think of it is the adjacent one is the side length other than the hypotenuse that is used to create the angle. If we recall the definitions of the three primary trig ratios, then we can say that sine of x is equal to the opposite over hypotenuse, cos is the adjacent over hypotenuse, and tan is the opposite over adjacent. You might have learned in grade 10 that we have the saying for that is SOH CAH TOA, where we can create three triangles, SOH CAH and TOA, that remind us of our basic ratios. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So, given angle x, we're going to label the side lengths here: the hypotenuse, the adjacent, and the relative, and the opposite angle. So for the first one, I always start by stating, well, the longest side length is going to be my hypotenuse. Remember, it's always opposite that right angle. The other side that's touching x is going to be my adjacent, and the side that's not touching x is my opposite. In the second case, if I'm using y, well, the longest one is going to be my hypotenuse again. The one that is touching y is going to be my adjacent, and the one that's not touching y is going to be my opposite. If I'm stating what sine of x is, well, sine of x is going to be the opposite, which is created by side length d to e, divided by the hypotenuse, which is side length f to e, or e to f. It doesn't matter if you put them in the opposite order. If I'm stating what cos is, well, cos is going to be the adjacent df, or fd, divided by the hypotenuse. So I'm going to call that df over fe. And lastly, the tangent is going to be the opposite, de, divided by the adjacent, df. For the second case, sine of y is going to be the opposite, SV, divided by the hypotenuse, VT. Cos is going to be the adjacent, ST, divided by the hypotenuse, VT. And tan is going to be the opposite, SV, divided by the adjacent, ST. In solving problems in right angle trigonometry, we need to be given a right angle, a side length, and one other angle or side. So we always need to know the right angle exists. We always need to have at least one side length, and then the other case can be another side length or another angle. The following points emphasized in the right triangle diagrams below. The opposite and adjacent sides can switch depending on the angle being used. So we can see that here. If I'm looking at angle A here, then here's my opposite and here's my adjacent. If I'm looking at angle B, so the other angle in the same triangle, then here's my opposite and here's my adjacent. They just traded places. The Pythagorean theorem can be used if two sides of the triangle are known and the third side is required. So that's just going to be c squared is equal to a squared plus b squared, or a squared plus b squared is equal to c squared. Just remember, if I'm trying to solve for one of the shorter side lengths, I need to rearrange my equation. So if I was trying to solve for one of the legs, like leg A, then a squared would have to equal c squared minus b squared. So I'm going to use the Pythagorean theorem to calculate the length of ST. Well, if I'm trying to solve for the length of ST here, then I can say that ST squared would equal the hypotenuse squared minus the other leg squared. Or ST squared is going to equal 625 minus 49. If ST squared is equal to 576, then I'm going to square root both sides and say that ST is going to equal 24. If I know that's the case, then I'm going to state as rational numbers the value of the following ratios. So if I'm starting with angle R, then sine is going to be the opposite, which is that 24, divided by the hypotenuse, which is 25. Cos is going to be the adjacent, which is 7, divided by the hypotenuse, which is 25. And tan is going to be the opposite, 24, divided by the adjacent, 7. If I am doing the same thing for S, then suddenly the sine becomes 7 over 25, and cos becomes 24 over 25, and tan is going to be 7 over 24. So you can see that if I'm looking at the relationships, sine R is equal to cos S, sine S is equal to cos R, and tan R and tan S are reciprocals. If I'm calculating angles in right angle triangles, then we're going to use the SOH CAH TOA method in order to solve it. In the diagram, we're required to determine the measure of angle X from the opposite side length of 6 and the adjacent side length of 5. In this case, if this is the opposite and this is my adjacent, then the only trig ratio that has opposite and adjacent is going to be the tan ratio. So what I would do is, like it says, I would start by stating that tan of x is going to equal opposite over adjacent, or 6 over 5, which could be 1.2. If tan of this is equal to 1.2, then the measure of angle x can be used by using the inverse tangent, or the tan to the -1 button on your calculator. In order to isolate angle x, I'm going to put tan to the -1 of both sides, and state that x is equal to tan to the -1 of 1.2, because that's going to cancel out the tan. Tan to the -1 and tan are going to cancel each other out. And if I put into my calculator, making sure that my calculator is in degree mode, so if you're coming up with a weird answer, go back in and check to make sure you're actually in degree mode, then we're going to state that it's going to be 50 degrees. So, if a telephone pole is 12 meters high and is supported by a wire 14 meters long fixed to the top of the pole and to the ground, draw a sketch to illustrate the solution or the information and calculate to the nearest degree the angle between the wire and the ground. Well, I'm going to say that I have a pole is 12 meters high. I have a wire that's connected to the pole at the top and connected to the ground, and that's going to be 14 meters. And then I have the length along the ground, which I don't know. All it wants me to figure out is what is the angle between the wire and the ground, so I'm looking for this angle here, which I can call x. So in this case, I know the opposite, and I know the hypotenuse. Well, the only one that has opposite and hypotenuse is sine. So I can say that sine of x degrees is equal to 12 over 14, which means that x degrees is going to equal sine to the -1 of that ratio, 12 over 14, which is going to equal approximately 59 degrees if we're doing it to the nearest full degree.